This conference will now be recorded.
Okay, so let's go look at the structure of an RPM real quick. And then when you look at the man page, it's just really gonna help you out some. So let's look at here. All right, so here they're just talking about what you need to set up to create an RPM. And as you can see here, when we create the structure of what we want our RPM or our package to have, we have a build, we have a set of RPMs, we have sources, we have a spec file and source RPMs, right? And then in here, we're going to create what we call a macro. So don't worry about this. It's not on an exam. I'm just walking you through this. Somebody will probably ask you to create an RPM. All right. So let's skip past this because I want to get down here. So here is copy the files under the source directory. So what files do I want to have inside of my RPM? So here I have a list of files that I'm going to store under RPM build sources, and I'm going to put a list of my files inside of here, right? And look, here's that tar command that we're going to learn about tonight. We're going to use tar, and tar comes with a set of options, right? C for create, Z for uh, basic compression, and F is the file that we want to name. We're naming this file here, and then we want to store this information in that file. And it's gonna, and looks like that's probably gonna be placed under here. And then we're gonna create what we call the spec file. So when we, and I'll show you this about RPMs too, because this will be a build up to our next class with RPMs. Here we're giving it the spec file of, well, what is in this package, right? In this package, we got the version, the name, a summary of what it is, the group that's associated with it, where you can find the actual repository for this. And look, there's that tar file, that source. And then we write up a description, and now we're telling the package what it needs to do when somebody installs this RPM. We're giving it a set of steps of what it needs to do, right? Come back. And then once we get that set of steps, we build that RPM based upon that spec file, and then our output should be what we're naming it: my dump admin uh, dash one dash o dot no arc RPM. And then we can install that, and it's going to walk through these very same steps right here in order to do everything. And that's the creation of an RPM. So when you see this here, this name, this info, this man page, all that came out of building an RPM and building a man page um and giving the man page, giving you actual help of what that package is, right? So whoever created this unzip package, you say thank you to them, because now they're giving you what your options are. So that's a little history of how things came about. So here you have our options down here, the dash X, the dash D, and so forth, right? So when I was talking about the packages, if I do a yum info on unzip, you can see that release, that source, that repository, the repo, the summary, all that stuff gets shown to you here. And that all came from that spec file that you saw for RPMs, right? Pretty cool, right? You could create your own RPM, and that RPM could do nothing but install a text file that has your name in it in a directory that you created on every machine. Like you can call it the Tamika RPM or the Lori RPM or whatever, and all they do is install a file somewhere, right? So that brings up another point about security. Remember, we talked about supply chain before. Remember, if I created an RPM and I give it to you and I tell you to install it, are you going to install it onto your system and you don't know what my intentions are? You don't know where it came from. You don't know if it's a clean RPM. You don't know what's in that RPM that could do whatever it can, whatever you want, whatever I want it to your system. So we have to sign our RPMs. to give it like a pretty much a stamp of approval saying that this RPM has been signed. Here's the actual key that it has been signed with. If this key doesn't match that RPM, don't install it. Because I didn't somebody else excuse me, somebody else has tampered with that and I don't. So there's a little nuance that goes with that. Any questions so far? Okay. All right, cool. So, all right, so we got our goal for this chapter is to understand how to archive files and transfer files. So here, archive with tar, extract them using the tar command, transfer files to a remote system using SSH, and we'll probably use rsync as well and SCP. And then effectively and securely synchronize contents of files of a local file directory with a remote server copy, right? And then you have a set of labs. So we're gonna go through here. You all do the guided exercises. I'll do this. You do the guided. I'll do this. So basically 3 chapters, and I'll run through the guided exercises really briefly. I won't spend time doing them because those are for you. All right, so managed compressed tar files. So we are learning about tar. So let's clear our screen and do a man on tar because we know that's what we're learning about. And as you can see here, we have tar is an archiving utility, and then we have tar, and then we have different options that we can use on here, right? So we could do a dash A, a dash C, D, T, R, right? But we don't know what all those mean. So you come down here, um, and they kind of give you the long versions of some of these, like concatenate and so forth, and create. Dash C is for create, but let's keep going so you can see what each one means when you're looking at it. So to give you an example right here, the example command above written in the short option style. So here dash tar dash cvf, the name of the tar file. There's no Z in here. If it was a Z, it would be etc.tar.gz etc. So basically, let's play around with this command here. All right. Let's make some files. Let's make a directory. And let me do it as a regular user. So let's make a directory. Make dir. And let's just say let's call this file tar file tar tartar, right? If I do a ls, you can't see it, but it is here. The directory is here. I wanna, how can I change this background here? Preferences, colors. Um, can I make this white? No, hold on. Cancel. Bold. Default background right here. How do I change that? Use. Okay. All right, I think that did it because it's very hard to see. All right, so now clicking with gas now. You can see I made my directory called tardir. PWD tells me I made it in /home/student and directory is tardir. So if I cd over to tardir and do a ls or ls minus a for hidden files, you can see I got 2 hidden directories there, but that's just going up to the current directory. The dot is the current directory. So if I say cd to dot, it's going to leave me in my current directory. If I say cd dot dot, it's going to push me up 1 directory. And I know that because I'm in PWD, whereas before I was in tardir. And I also can tell by right here where I'm at too, right? So now let's go back to tardir. Clear my screen, do a ls again. All right, so now let's touch some files. Hello, Tim, I am. All right, let's go ls. So we created some empty files. That's all we did, right? But now I want to take those files and I want to put them all into one big compressed file. So I'm gonna use the tar command and I'm gonna do dash C for create, dash Z for the compression. That gives me the GZ compression. I'm gonna do V for verbose and then F for the file name that I want to name this particular file, and I'll just call it tam.tar.gz. And then at this point now I can just do star because it should grab everything in there. All right. And if I do a ls, I have a file named tar tam.tar.gz. Now, because I compressed it, I can remove hello, I am, and tam. All right. So they're gone. All right. But we know that we just compressed that file. So we know they're actually compressed inside that file. But we don't know that, right? I may get a tar file and I don't know what's in that tar file, right? So how can I get the listing and the contents of a tar file? So I can do a man on tar, and there's a option that I can pass, and I think it's the dash T. Let's go down here and find out dash T right here. That gives me just the list the contents of an archive. So let's quit. Let's do a tar dash T on tam.tar.gz. Uh-oh. Well, I have to my stuff. Yeah. All right. tar.t on tam.tar.gz. Refusing to do that. Why? Oh, because it is compressed. Mm. So let's unzip it. Yeah, I can do unzip. So we do g unzip tam.tar.gz, and then we do ls, and I just get a tam tar. Let's see now if I could do. Oh, why are you missing that? Refusing to re-archive contents, return missing the dash F option. Okay. Put an F behind that. It still didn't like it. Let's go and look and see. Why are we having problems? All right, man on tar. Let's go for the dash T. Let's see. See the dash T and then the archive. Hmm. Let's see something. I need to separate them. I don't think I do. I should be able to just do them like that. And that's no longer there. Okay. They didn't like it together. All right. So the contents, the list of contents, I passed a dash T and a dash F. It didn't like dash T and dash F together. Watch that. Watch. It doesn't like it. Oh, it liked it that time. I don't know why I didn't like it before. Ah. But okay, fine. It worked. So I passed it the actual file to look at, and so now it gives me that. But I want to show you. I want to compress it back. So let's gzip it back. Gzip tam dot tar. So there we go. So now we can see that we got rid of those files. They were there. So now I'm going to do a tar dash X to extract V verbose and then the file tam.targz. Remember, it was nothing in the directory, and now the stuff is back. And I can do the same thing all over again. I can remove hello, I am, and then tam, and I can do an ls, and I can on tar. I can just go back again, and I can uh, untar that file with the X for extract V for verbose because I would just want to see everything, and the F. I could take the V off, and you would just see nothing, and then when you do a ls, you would see that the files are there. Any questions so far? No.
Late to
No,
the
you
game,
make.
I wouldn't know what to ask anyway.
No, it's a profile that you have to create inside of IBM. I think D posted that link earlier. And if not, we got some other stuff that I want to go over too.
I have a question. I thought when we remove files, they're gone forever, like they're deleted.
So that's a misnomer on all operating systems.
Okay.
What happens on all operating system is um, the file is still there. That's why they tell you that if you don't encrypt your drive or something like that, if you delete something, the file is actually still there. What gets removed is just a pointer to the file. In our case, the file got removed, but they're compressed into a tar file. And so once I compress them into that tar file, the tar file contains those files. So then I just untar that file and then it creates those files right back again.
Okay, because I thought the reason that it wasn't working with that one
Options.
command was because we removed them. Yeah, with the
Mm-mm,
options.
mm-mm.
Okay.
Nope. So let's do this again. Let's leave that there. Let's make a directory. In this directory called um Linux tonight. All right. And then let's move hello. Move meaning I'm removing it from where it's at to Linux tonight. Move IAM to Linux tonight. And then move Tam to Linux tonight. Right. And then I can say touch Linux tonight, new files. And then if I do an ls on Linux tonight, you'll see now I have hello, I am, new files, and tam. I didn't have to be in the directory. I just touch is just an easy way to create a file, right? Now I'm going to take this very same now instead of tarring up files, I'm gonna tar up a directory. So now I can say tar dash C for create, Z for compression, V for verbose, file, F for file. And now I'm going to give the file a name. And we're just going to keep it simple, Linux tonight tar.gz. And now, got to remember now, let's break this down. This is the command. These are the options that I can use. Followed by this, when you type this F, it's usually the last thing that you need to type when you're tarring up a file or unzipping a file. And then you give it the file that you want it to do the action on, like this is the file name that you want to create or the file name that you want to extract information from. And then the next part is um this part here is I'm giving it the file name. Now I'm giving it the directory I want it to tar up, right? So I'm gonna hit enter. And it's saying, hey, I tarred up Linux tonight, hello, I am Tam, new files. So it's clear. Let's do it ls. We now have two tar files here. Right. Now let's see if our command works this time. Dash T dash F and then Linux tonight.tar.gz. Now it gives us the listing of what's in the file before I extract the file. Right. And now I'm going to remove that directory, Linux tonight, right? rm-rf removes an entire directory. So now I just have two tar files here. Looks much cleaner, right? Now I want to extract that file. So I'm going to extract that Linux tonight .tar.gz file. So I'm going to use the X for extraction, the Z, oh no, X, V, and then I'm gonna pass the F. I think I may need the Z. Hold on, we'll see. Yeah, I didn't need it. All right, so I extract verbosely and then the file. And then when I do ls, I got the directory back. And if I go over to that directory, cd to that directory, and do ls, I have the files. So the tar file is a way to compress a lot of different things that you want and then give that to someone versus I may have 15 files in a folder somewhere. I don't want to send you 15 files. I just want to send you one big file. Right. All right. So here they go into talking about archive files and directories into a compressed file with tar and then extract the contents. Right. An archive is a single regular file or device file that contains multiple files. When we saw that, it says the device file could be a tape drive, and it could used to be you could read. I could use tar command to read from a tape and write to a tape, a flash drive or removable media or CD. As long as the CD is read or write or whatnot, and you have a read write CD-ROM drive, you could do that as well too, right? People, I saw a post today that people were like, no one uses tapes anymore, but yes, they do. People are still using tape. Microsoft, not Microsoft, but AWS actually has um, AWS tape drive. They actually have one. Tape gateway right here. They store stuff to tape, right? They actually have a whole tape library archive or whatnot. AWS Snowball, where they get a truck that comes out there that you upload your stuff to, and they bring it to the data center and so forth, right? There are companies, i.e., your big time companies, like all your big research centers and stuff like that. The CDC and stuff like that. They still use tape. They still use tape, right? They still use tape for their to archive stuff. Um one of I think tape here was just customer. Let's see if we can find if their show eh, one of the biggest customers that they have. One of the probably it's NASA is probably one of their biggest customers. Anything dealing with pictures and satellites and GPS and all that stuff, trust me, they archive those things. Let me see if they got a what's driving tape storage. Look, what's driving the research in tape storage usage, right? People are still going back to the old ways of backing up stuff and storing it and keeping it. And sometimes you gotta have stuff on file for 10 days. There's an old article out there where Google at one point in time lost a lot of people's Gmail boxes. And you know what? You know what they had to restore from because they have your Gmail box is synced around the world, right? So if I delete here, if I delete in this particular region, it's gonna sync up and delete around the world, right? You know what they had to do? Yep, they had to go. They had to restore from tape back in the day. Gmail restored from take well, it's an old story for that. Let me see if I can find that. It's give me everything. I don't know why Kim Kardashian shows up as the restore for tape for Gmail. We'll go to all. Yeah. 2011, Google turns to tape to rescue lost Gmail. Right? That's an old story. So yeah, restore a user's permanent deleted email, right? This article is for admins. If you want to restore a deleted message for your personal Gmail account, go to delete or recover deleted email and Gmail messages. And they can pull that stuff from tape, right? That's how they were doing it. And so a lot of people think people are still not using tape. They are, they're just not carrying around big LTV drives to restore. But in some cases, in a lot of cases, if you're in a skiff and you're on prem and you're not pushing to the cloud, you probably have a tape that you're storing to because there's a federal mandate from the government for you to keep data of people and their email addresses at least from I think it's 5 years or maybe 10, but I know you got to at least keep it 5 years. Even after they have left, you have to keep it on deck for 5 years. So you imagine how much turnaround it is if you hiring 1,000 people, they all work in a skiff. You got to keep their storage, their data for 5 years. You know how long that is? You know how much data that is that you got to keep, and you got to keep archived. So you need to pull up an email from said person from X, Y, and Z. Hopefully you can go pull that, or if they deleted their email from their directory, I mean from their, from that area, hopefully you archived the email from 3 weeks ago and you can go pull that email, right? So that kind of stuff. All right, so here, back to the archives, which we were talking about. Um, um, the original ubiquitous zip compression and the file packaging utility PKZip algorithm, which has evolved and is supported by Rail when using zip and unzip, which I showed you earlier. Right, archive files are used to create manageable personal backups. Right, or to simplify a task of transferring a set of files across a network, right? I don't want to give you 1,500 files when I can give you one big tar file, right? Now, you have to be careful with the big tar files too, because the bigger you make them, the longer it take to transfer, right? All right, so here it is, like on Linux, the tar utility is common command to create, manage, and extract archives. Use the tar command to gather multiple files into a single archive, which we did. So here, C for create, T for listing, and X for extracting. You saw that. You saw that I used verbose, and you saw I used the -F. These are the five probably common ones you're going to use. You may want to use the P to preserve the actual permissions on that particular one, and they say preserve the original file permissions when extracting. Right here, enable extended attribute support and store extended file attributes. So here they're talking about uh, uh, um, extended attributes here, and also talking about SC Linux here. Like if I tar up something, they have some SC Linux support, some file contents on them, and I want you to have those as well when you download them. When you extract this file, then that'll be on those particular items in that tar file. Auto compress. I haven't used auto compress, but most definitely I have used gzip, bzip, XZ compression, and then the -Z. I haven't seen this out a lot, right? I haven't seen this one, the capital Z, but most definitely I've seen these three here, right? You'll get a file that .tar -XZ. You'll get a bzip2 based on and they tell you the bzip2 compression, the gzip compression, right? Remember when you have WinZip and so forth, those are compressions as well too. All right, so create an archive. Well, we went over that. Tar -C for create, -F for the file, the name of the file. But notice they didn't pass it the -Z because they didn't do the .gz on here, so it's not compressed. But now you see you have these three files that are going to go into this one tar file, and that one tar file is called my backup. So let's play with that command. All right. Let's go run through it again. What they have right there, right? So let's see the up. They have a set of files called my. Let's just grab this right here. We're gonna touch. And in order to cut and paste, I have that off. I'm gonna type touch. And ooh, I'm gonna go one more directory. Oh no, that's fine. This directory is fine. All right, touch. And then we should be able to paste. Hold on, let me see if it works. There we go. All right, so now I pasted that in. I'm gonna hit enter, and now if we look here, we have three files with ending in .log, right? And then there we're gonna take this command right here. All right, first I had to create what they had, right? And now I'm gonna take that command and I'm going to paste it in. And now I'm going to create that very same file that they have. And we do ls. And now you can see I have my backup.tar file. And we can see what's the contents with a tar-tf of my backup.tar. And you see those files are there. You see notice the difference. There's a -gz on mine because I did further compression on it with the gzip, right? All right, now in here, they said a user must have read permissions on the target file on the target files being archived. For example, root privileges are required for etc directory, of course. An unprivileged user can create an archive file in the can create an archive of the etc directory, but that would contain files that cannot be read by the user, right? Because you can only you have to be root, or you have to be a part of a group that root is a part of, usually the wheel group, and then root has its own group as well too, so you can add it to that. You can cheat and add it to that, but most people create another group and then add those users into that group, and so they can get access, right? So here they're showing like, hey, removing the leading slash for member's name. Basically, if in this example, the root user creates the /root etc dash backup dot tar archive of etc. And you can tell this root by looking at the # here. And I kind of went over that indirectly. So here if I say, who am I? I'm a student, but if I sudo su dash, should be able to just do that, but that's fine, student. You can see that it went from $ to #, right? That lets me know that I'm root. Now, that only truly works by knowing that you're in this particular shell, the bash shell. Certain shells have a # as one of their I don't want to call it marker, but what's part of their setup. And so therefore you could not, if you're not in the bash shell, it could be something else, right? All right, so then it says we want to list the contents. We did that. We made a directory and we extracted that. We got a listing of what it is in there, and then we extracted that. But here's the -p, right? We want to preserve the permissions, so we pass the P option. If we want to preserve the permissions, right? Says when you extract the files from an archive, the current UMask, which is on this was probably 002, 0022. All right. So if I want to, when I untar this file, it's gonna get the permissions of whatever this UMask is, right? And you gotta remember, files. Let's see, directories start at 777, and then files are 666, right? So when I say that, when I go to make a directory, what ends up happening is it gets permissions of 0777, but the UMask is 00222, so it subtracts uh, 0 from 0, 7 from 0, 7 from 2, and 7 from 2, which gives us what? If I gives me 755, 0755. So when I make a directory called test, if I do a LL, you'll see that I get 755 RWX. All of them on. All the permissions are on. R is worth 4 points. W is worth 2 points. X is worth 1.7. I mean, 4 plus 2 plus 1 is 7. Again, 4 points and then 1 point. That makes it a 5. 4 points and 1 point. That makes it a 5, right? R equals to 4, W equals to 2, X equals to 1 in terms of permissions, just to keep it very simple, right? So what you're looking at is I have a directory, because the D is in front, that has permissions of R plus W plus X, and that equals to, what it comes down to is 4. Yep, read, write, execute. Yep. 4 plus 2 plus 1, and that equals to 7, right? So the next one over, and we got to remember here, this is user, this is group, and this is other, right? All in threes. User, then the group permission is that one, and then the other permission is that. So if you're not a part of this group, you can't read or execute this, right? So here we're gonna type a comma, and I'll say that equals to user. That's the user group. And then the next one is just R plus X, which is what number was R plus X? If if R is 4 and X is 1, that is 5, right? And this is the group. And then R plus X again is what? It's 5. And then this is which is equal to other, right? So that's how you read the permissions. It's a directory, and the permissions are 755. How did it become 755? Because directories always start with 777. When you create a directory, it's going to start with 777. The U mask, which is 00022, is going to then say, okay, you just throw a 0 in front of the 7. 0 minus 0 is 0. 7 minus 0 is 7, or 2 from 7, and 2 from 7 is both are 5. So that's how you end up with the permissions here of this 755, and that is for the user, the group, and other. That's just a quick way to remember your permissions, right? 4 plus 2 plus 1, that's what you get, right? So just for now, let's see here. Control C. Oh, why am I not in there? Something's going on here. Okay, cool, clear. All right, so clear. What happened to my keyboard here? I don't know what's going on there. Don't know what happened there. All right, so if I do a ls minus etc, and I'll just type aliases. Ls minus l, sorry, or ll. What are the permissions on that particular file? It's already been created. What are the permissions, right? We know it's a file because uh, the very first item right here is a dash, so we know that's a file. But what are the next set of permissions? We got read and write, right? But read and write, we got 4 plus 2 is what? Right, 6. The next one, it only has 4 plus 2 zeros. What is 4 plus 2 zeros? All right. Yep, we got read, write, read, but what's the permissions though? What's the numbers? 644. Oh, come on. I don't know what's going on with that. Right, 644. And we got 644 because we see right here we have R plus W. So 4 plus 2 is 6. And then we don't have any permissions right here on these last two. So it's just 4 and 4, right? R is 4, right? Remember that. It's all good. You're learning really quickly. R equals 4, W equals 2, and X equals 1. And together they are 4 plus 2 plus 1, and that equals 7. All right. So let's go over here and look up some more permissions real quick and do it ls. Okay, so let's go look at let's look at this one here. Let's look at this. Let's look at this. First off, is this a file or a directory? The very first, it's a directory. The very first thing should tell you that if it's a file or a directory. So we know it's a directory. But what are the permissions on the directory? All right. For user, group, and other. For user, it's what? Correct. For other and for group, it's what? Yep. So the whole thing, it is for this one, it is that was is a directory. And permissions are or were 755, right? That's what it was. So the more you look at this, it's gonna get better. So let's play the game here. Let's see. JC, I'm gonna call on you because you learning and you're gonna learn real quick. You can come off of mute. Let's go. Let's look at you didn't learn that yet, but let's look at this one. VIRC. VIRC is what we're going to look at. First, let's determine if it's a file or if it's a directory. Which one is it?
That's a regular file.
Okay. And then the user permissions is what?
The user just has read permissions, and the group has read permissions.
The user
Is that?
has read and write permissions.
Oh, excuse me, read and write permissions. I had to zoom in. Sorry.
Right. All
Yep.
right. So with that being said, what's the numerical number for read and write if you had to add them
Oh,
up?
I was having a hard time with the numericals.
All right. So
I can't even do it.
listen, it's real simple math.
Okay.
R equals to 4. Let me put it
Yep.
in let me put it in terms, right? Basketball terms. I get 4 points for
Okay.
R. I get 2 points for W, right?
Okay.
So 4 and 2 is what? 4 plus 2 is what?
6.
All right. And then
6.
the next one is the next one over. I just have an R, right? And R equals to
All right. So
4.
that's 4.
So I only get 4
Yep.
points. And the next one I only
Yep.
get 4 points. So
4
this one is
points.
644.
Yep. Okay.
All right. And remember, everything is broken into threes. Like this very first column here, all the way down, that first column. You see a D, then you don't see nothing. That's an actual file. This one right here is a link. So I didn't give you all
That's a
that.
soft link.
That's a soft link. That's correct.
Yep.
So here the R and the W is 4 and 2. And I don't have anything in this last situation of last octet, if you want to look at it like that, of these permissions. So I just got 4 and 2, so that's 6. The next one I got 4 and I don't have nothing, and
Yep.
then the next one I got 4 and I don't have nothing, so 644. Let's try it again.
Okay.
Let's look at VMware tools right here. Was it a file or a directory?
That is a directory.
Correct. What's the permissions in the first? When we're just looking at the user. Remember, we're broken up into threes, right? RWX.
The user has all permission.
All
The
permissions, but
user
what's
has all permission.
right? But what's the
Oh,
numerical
is
number?
it 7-7?
It's
Is it
4 plus
7-7?
4. It's just 4 plus 2 plus 1, so it's just 7.
Oh,
And
yeah,
then
7. Okay.
what's the permissions on the group, which is R and X? That's the next set. So what's
Just
4
read
plus
and
1?
execute.
Right.
Yep.
But
So that's 5.
4 and 1. right? And then the next one is read and execute is 1. It's 5.
5 as well.
So
Yeah.
yep. So this directory has permissions of 755.
Okay. Now
You
I remember.
following along
Yep.
with that?
Yep. It's been a minute since I've done this, but yeah, I remember.
Yeah, so you got to remember everything in threes for this one. Everything in
Hmm.
threes. If I can highlight this RWX, and then the next one over be R and X, and then the next one over
Hmm.
is just the R and X right there, right? That's all your permissions,
Yep.
right?
Okay, this is Japanese to me. I do know the R, the W, and the X. That's 7. But after the read, that is 4. What's the dash for?
The dash meaning ain't nothing, ain't nothing cracking,
Okay. Because you
ain't
did
nothing.
say
Means the group doesn't
you
have
group
permission.
them in threes. I got that part.
Right. The meaning that's not on, that bit's not on.
Okay,
The
so
D
then
is for directory free.
the directory, the reader, write, execute, reader, nothing, execute, and then reader, nothing, execute. Is that right?
Correct. The meaning they can't write to that directory. Meaning
Hmm.
the user, and it goes like this. It goes UGO, all right? User group other. Then that equals to user um, group and then other. So that's what you're reading. In each one of these threes right here, that belongs to the user. The next
Okay.
one belongs to the group, and then the
Mhm.
next one belongs to the other.
Okay.
All right. So what they're saying here for this first set of threes, for the user can do anything. I'm fierce. I can do whatever I want to. But you other stragglers, you other groups, and your others, you can only read and execute. You can't write in my directory. Back
Right.
up.
Okay.
I'm not giving you permission to do that. Now I have the option to change those permissions. I can change those permissions.
So that's when I see a program that says you don't have permission to do anything in this file. Okay, I
Well,
got
yeah, yeah.
it. Yeah.
You ain't got it, Sway. You don't have the answer, Sway.
Okay.
You ain't got the
I'm
answer, Sway.
learning. I'm learning.
You ain't got the answer, Sway.
In
Right?
3 weeks, I'm gonna be installing Linux on my
You
computer.
are. You gonna be doing that this weekend.
Okay.
You gonna do that this weekend.
I mean, I'm already reading while you talking. Like, what is Linux? I know it's another operating system, and it has several different pieces. It's got 7. The bootloader, the kernel, all of that. I'm getting it.
Come
I'm
through.
getting it. I'm coming.
Come through. Come holler at me when you want to talk about kernels. We'll talk about it in a minute. Let's get through this, and then
Okay.
we'll do our big overview of the kernel and the breakdown. We'll talk about operating systems tonight
Okay.
as
Okay.
something that is common that people don't really talk about, right? We'll talk about operating systems. All right, so user group other. All right, these permissions are the lifeline of things that you can do in Linux, right? These things help you to secure your operating system or files. They also help you understand who has access to what, right? So whenever you're doing something, you're like, oh, well, I need to have permissions to do X, Y, and Z. Oh, I don't have permissions. What user is available that does have these permissions? Can somebody give me permissions? These things, right? These things happen quite often on Linux systems, right? Now, what we were working on, let me go back and exit here, gets me back to who I am. I always check so you know who you are. Who am I? I am a student. So in that directory, I had these tar files, these blank files, just nothing in those files. I'm gonna show you how to write a file using touch, but no, using echo, but it'll have something in there. So I could do echo um me fi me into me dot text, right? And all I did was take, if I do just this first part, echo me fi me without the redirect here, it's just going to echo that out to the actual screen. But what I did was I redirected that information that instead of going to the screen, it now goes to a text file that I created. And now if I want to read that file, I can use Vim, or I can just say cat me.txt. And now I got me fi me. All right. So that's just another way to create files. But with that being said, if we do a LL on that, remember,
I got a question.
go ahead.
Okay, when you're doing the redirection, when you do 1 caret as opposed to 2 carats, I'm trying to remember what's the difference.
One
Like,
is one is create, the other one is append.
okay, that's right. Okay. All right, sorry.
So with me fi me, if I okay, let's back up here.
Hmm.
When I cat this file, I got me fi me in there, right? But I'm gonna go
Right.
back and do the same command I did again, right? And I'm gonna take off just the me part. And then I'm gonna cat that very same file again, and I just got
Hmm.
me fi. I overwrote what I had in there. If
Right.
I had me fi me, all right, we're gonna put that there, and then we're gonna do the double caret, right? Or double greater than. And now when we cat that file, it appended it to the end of the file.
Okay, now I remember now. Yep. Okay.
Yeah.
Thank you.
Right. So a lot of people get caught up with making for loops, and they'll be doing this, and instead of appending to the file, they just keep overwriting the file, overwriting the file. And he use a double caret to append to it. Right. All right, so permissions. All right, so it says here you want to extract files from an archive. The current UMask is modified. We looked at the UMask. We also looked at when we use UMask to create directories and files. So I wanted to show you that so you understand this context. Is used to modify each extracted file permissions. Instead, use the tar command with the P option or -P option to preserve the original archive permissions of the extracted file. So when I extract that file, depending on what my UMask is on my new location of where I'm going to, it's going to assume that when it creates that file, remember the file creation is 666. When it creates that file, if my UMask is set to 00002, my new files are going to take on that new permission. But if I want to preserve that file when it's extracted, if I want to preserve my permissions, then I pass the -P option to preserve my permissions. Don't mess up my stuff, right? Don't mess up my stuff. Here they're showing you the gzip, the bzip, and the xz and the compressions, right? When we talk about compressions, when I send you a tar file, or when I send you a WinZip file, or when I send you any type of compressed file, or I'm sending you something that's compressed by some type of algorithm or something like that, right? So here they're saying, hey, C, we're going to create here. C, we're going to create a zip file, and we're going to pass it the file name. Not only, and then the path I want that file to be created in, and what I want to be stored in this file, right? That's what that is. That's what you're doing there. Here, they're showing you, hey, create a bzip2 file. Well, to create a bzip2 file, you're going to pass it the -J option. C for creating, J for knowing that you're going to do bzip2, and then the file name and the path and what you want stored in there. And the same here, look here. You got little j, capital J, because you're using the XZ compression. And this is how they show you how to create the XZ compression. Same file format. The same format for the command. The command name, a pair of options that I want to use. I ended it with an F because I want to create, and I have to tell it what that is. But I'm also telling it the path in which I want it to create that tar file or that compressed file. And then I'm telling it what I want it to be in that particular file, what contents that I want to be in this file. Right? Same thing here. I'm listing the contents of that, right? Now to extract these things, right? I'm doing a listing again. I'm just listing, but then that's to extract these things. I can do a list with gzip. Here I can do a list with xz for if I have a file compressed with xz, right? Whatever I compress this with, like here for gzip, you could probably do tar as well too for this tar file. And if tar doesn't work, try gzip, depending on how someone made that file. But they're showing you how to read the contents without extracting the information, right? And here we're doing the same thing there. And here they're showing you how to create. Now, how do you untar that? So let's go here. Let's grab this here. Let's go back onto our machine, and let's clear and let's paste, right? Let's just put it in our directory. We don't want to be in root. Let's go error out. All right. So now let's just let's do my. Let's see if it take it. It should be able to do star.log. All right, so let's do that. So what I did was I did a wildcard and said grab everything that ends in .log, right? So now we did an XZ on that, right? So now we have, if we did our ls, we see a file called sshconfig.tar.xz. So if we wanted to read the contents down here to say just pass xz-l and that file, but that may not work. Let's see. Oh, yes, then index, so that'll work. So xz, I thought I did it with a tars -l ssh config. Okay, so it gives us the blocks, the compressed. Oh, I wonder, do I have to pass the -f? Oh no, it just gives us this. That's right. It gives us the blocks, the compressed, uncompressed, but it didn't give us the listings. So let's go and look at a man just out of just for shits and giggles here. Let me pass the -f and see if it does the same thing. No, it doesn't. So let's go look at a man on XZ. So let's clear my screen. Let's do a man on XZ and see if it'll give us a listing of what's in there. So here, standard out, I just want to get what's in the contents of it. So what are my options? That's what I'm looking for. What are my options? And let me go down here. Okay, here we go, options. Operation mode. So we got a Z from compressed, T to test the integrity of it. The -L is supposed to print out information about compressed files. No uncompressed output is produced and no files are created or removed. The default listing, blah blah. All right, so I'm missing something. I didn't get what I wanted to get. So let's try that again. So I didn't get my information like I would when I do a tar dash TF on tam.tar.gz. I want that information. I want to know what's in there. Let's see. Let's do this. Let's uncompress that file. Let's make a directory called xz info. All right. And then let's move ssh config over to xz info. Right. Let's cd over to that directory. And then let's uncompress the XZ file. Remember, if we scroll back up here, in order to uncompress, I had to pass a tar-c capital JF. So let's grab that and come back over here. F, thank you. And what's the name of that file? SSH something. Don't like me. All right, so tar F ssh config .tar.xz. I wonder if anything is in there. Oh, what happened? We're doing here. There we go. Cowardly refusing to create an empty. Oh, I did this. I did a C. I need to do an X probably. Okay.
I don't see your
Yeah.
screen.
Oh, you don't see it no more?
No, ma'am.
Uh-oh. That's probably what happened. I was like, what happened? What's going on? Let me close this out. See it now?
Yes.
Okay. All right. So let me back up and show you what I did. All right. So where I write my screen, there we go. Let's clear. Let's remove star.log. Cool. Everything's gone, right? So what I did with the up arrow gets you back. I did tar, which is the command, my options, X to extract, capital J because of the type of compression, and then the file name here. And it extracted that information. So there's actually something in there, right? And let's do ls, right? So when we did the tar or the xz-l, and I wanted to show you that. I'll show you that in a minute.
Wait, so when you did the tar X, no, not the tar CJF, you were
That was
copying it to
that was to create. That was a mistake.
create. Okay. All right.
Yeah. So again, C to create, X to extract. So I extracted the file, right? Using the -X, but I also wanted to know what was in that file, but it wasn't giving me what I wanted to know what's in there. And I didn't get that, right? It just told me what it was compressed and so forth, but didn't give me the listing of the files like tar did. So when I extracted here with the -X capital J and then the file F and then followed by the F, when you put the F, you have to put the file that you're gonna do the operation on. It gives me the stuff that's in there. So my original command when I did this wildcard, and we can do clear and we can do history. When I did that wildcard command, let me scroll up right here, 1-on-1. It took whatever was in it in .log and put it into this compressed XZ file. And that dash C was for create, the -J and then F. And then when I wanted to extract that information, I came down here and I want to extract that information with the -X, the -J, just like you would if you were doing WinZip, compress and then extract. Right? Same thing. All right. And so that is all of that one. Then they give you a guided exercise here. They have you go and log on to the workstation. You run this command. It sets up your lab. They have you SSH over to server A, and they have you run through commands. That's what you're doing in here. And then they have you set it back to what it was before. And that's why I say each lab is independent. So it's not like a build up. You reset every single time. So you can start anywhere in the actual class. So next up is how to transfer files between systems. SFTP, rsync, um, SCP, and so forth, right? We ran out of time, but we'll finish this off next week. And then they have a lab for that. Then over here, they're using rsync. I like rsync over SFTP. And they go on from there and they show you how to log in and then how to rsync files back and forth, right? So again, the command, the options, the source, and then the destination. And when you look at the actual uh, setup of when you look at the man page for rsync, it'll give you how the command is actually laid out and then what your options are. All right. And then here they're just rsyncing files. You can use rsync files to different servers, right? So here I'm on my local machine and I want to go to host A and I want to store var log, whatever's in var log. I want to verbosely see everything, right? And then I want you to put it in /temp on that particular host. Same thing here. I want to rsync stuff off of host A and put it into /temp on my local machine. So one is a push and then the other one is a pull. This is a push to from my local machine to a remote machine, and this is a pull because I am pulling from a remote machine and storing it locally. Push and pull. You can do that with rsync. Right? And that's what they're showing you there. And we'll go more into it next week. So I know we only got like a few minutes, so I'll just do a quick rundown here because I don't want to hold you all longer. I know you got lives and stuff like that. So kernel and operating systems. All right, so um, Windows has a kernel, so forth and so on, and mostly all your Linux boxes. All right, so um, operating systems and kernels, right? Geeks for Geeks, they just came out with a little something, but here you can look. An operating system is a system program that provides an interface between the user and the computer. That's great. That really didn't tell you anything, right? And the kernel is the core component of the operating system. It is also a system program. But here's the main thing: your kernel is if you want to call it, this is probably a bad way to call it. The kernel is allows you to have access to your hardware. So with your kernel, I have access to the memory, I have access to the keyboard, I have access to the monitor, I have access to the hardware. And the operating system, um, the kernel is a part of that operating system, right? But without that kernel, that operating system is nothing without it. Your kernel is your friend. So these um, packages and these things that get created are very important, right? So the kernel is the core component of the operating system. If you got a messed up kernel, then your operating system is going to be messed up. All right. And it tells you here, it's also a system program is part of the operation which users convert commands into machine languages, basically. I type in CD, that tells that tells the actual system to do something, but it's translated into machine code, right? And then here it says the operating system is software system. The kernel is a software system which is part of the operating system. It also provides protection and security. Its main purpose is memory management, disk management, process management, and task management. I'm a manager, right? I'm the operating system. I'm managing. The kernel is doing. The kernel is a doer. Oh, you want me to move files to X, Y, and Z? Oh, okay. Well, that has to translate into machine code in order to do X, Y, and Z, right? But the kernel types of operating system include a single multi-user OS, a multi-processor OS, a real-time OS, a distributed OS. A type of kernel includes a monolith or a microkernel, and we won't get into microkernels, right? But let's back up. Let's go look at some images because this is really gonna really help you here, right here. This helps you. The kernel talks to the CPU. I talk to the memory. I talk to the devices. I put a nice little operating system with a GUI on top, and then I install some applications on top of that. And that's what you get on your laptop. You got a nice little GUI that does some things, that move things around. But in actuality, you don't really need the GUI to do those things. It just makes it. Just imagine if you didn't have a GUI for your laptop, everything was command line. All you ever did was everything command line. That's what I do every day. Everything command line. Very rare am I in a GUI. However, do you imagine that if we all worked and lived like that every day? We go to, you get on your phone, you want to go to google.com, you would type in the IP address of Google and you would just be using IP addresses to go everywhere, right? So it's got to be user friendly, right? It's got to be something people can consume and actually use, right? So you had asked about that bootloader, right? One of the most systems, the kernel is one of the first programs to load up on start after the bootloader. It handles the rest of the startup as well as memory, peripherals, and input and output. Software translating data processes and instructions for the CPU, central processing unit, right? So when you start getting into what an operating system is and how things work, and this really shines when you start talking about embedded systems and microprocessors and understanding that at a lower level and understanding how to make your own kernel. Let's see, how to make your own kernel, right? Here you download, and this is here. You go to kernel.org and you can get the stable and you can download the tarball and you can create your own operating system if you wanted to, right? You grab the kernel, you tell it what hardware that you want to have the libraries for and everything, and you can make your own operating system for your own laptop, right?
My mouth is wide open right now.
Right? You can make your own operating system. What do you think happens on what do you think happens? Have y'all ever seen a PIC controller? You ever seen that? Just look at images here. Right. These little microchips right here. There is a diagram out there for this microchip that tells you the pinouts. When I say pinouts, what is ground, what is the voltage, what's input, what's output, where things are set up at. So let's look at a PIC controller diagram. Let's look at one. Um, that works, but that's not really what I'm looking for. Pin out diagram. PIC controller pin out diagram. That's what I was looking for, like that. So in computer engineering classes, I would grab a PIC controller. I would then look and see what my input, my output is, what my ground is, and then I will wire this up. And I would send it instructions in order to do what I wanted to do. If I want to create a thermometer, then I would get a particular PIC controller that would have the pinouts for me to create my own digital thermometer, which was one of the things I did in college was create a PIC controller, right? For whatever I want to do. But again, this gets into like, I'm telling you what I want you to do. I am the operating system. And if you want to look at it from that perspective, I am the operating system. I'm managing everything. I'm providing you with instructions to do what I need for you to do, right? Um, and if you go back over here to what they're saying here, you download the source code, you configure it, you build your kernel, you update your bootloader, and then you off you go. How to build a Linux kernel from scratch, how to create your own kernel. You can do all these things. These are little side projects that you can do. What does that mean? Why would I want to do that? Well, um, embedded chips and satellites and humans. There are some embedded chips in humans. But now we start looking at images like this, and now we're having these chips on satellites, and they're doing certain instructions that we want them to do. We are now having chips on on aboard machines or the chips in your washer and dryer that I'm sending instructions to do X, Y, and Z. Super huge community when we start talking about embedded Linux and embedded chips and embedded operating system and RTOS, real-time operating systems. Lifetime work, never going anywhere. Um, this work is never going anywhere. You'll always be employed with this work. Like real-time operating system for embedded developers, right? RTOS used in embedded systems. If you go take a look at Indeed, and type in embedded, or you can go anywhere else and look. And you start looking up embedded software engineer or just embedded Linux administrator. There is an embedded um book, embedded Linux engineer book. I have it at home, right? Building embedded systems, system performance, embedded Linux programming, the ultimate, these are things that people do research on and been around forever. Same, yeah, IoT devices, all of that, right? Here, just find a job. You don't need no zip code, right? So 22,000 jobs, right? You can filter out by, not location, but let's go remote. And I usually like to come in and I did this on Saturday and I like to do, you know, we pick a number or whatnot, see what it pulls back. All right, anything that's 150,000 and up. All right, so software engineer, enterprise, principal, mobile applications, Golden, Colorado, senior engineer, embedded software engineer, um, production engineer. You can even look up embedded Linux engineer.
Can you change the experience level?
Yep. The entry will take off that 1,100 jobs. Staff for site reliability engineer, SRE systems engineer, embedded Linux software engineer, Linux administrator engineer. I guess embedded probably comes up with that. But again, DevOps engineer, wouldn't be surprised. Lockheed Martin, yeah. This is probably the position that I don't know. This is Louisville, Colorado. So I'm saying this is probably the position out here. But the DevOps engineer, cutting edge team development, embedded systems, FPGA solutions targeting F-35s, F-16s, ADP, IRADs. You're probably doing security plus Linux distributions, DoD, working with encryption devices, CI/CD pipelines. You're probably 9 times out of 10 deploying applications onto some type of stack that is then housed on an F-35 to do something of its nature, right? That's what that is, right? So you're constantly working in Linux and so forth and doing X, Y, and Z, right? So it's still around sensors and algorithms. Like these jobs are like life term jobs, life term skill sets, right? And you may be quirky enough to go into it, right? I had someone reach out to me recently and said they're doing high performance computing and they're managing stuff in AWS and I think GCP, that multi-cloud setup. But again, um, high performance computing has been around forever. We're never going to get rid of high performance computing. That's just something that we're going to be around. But embedded systems and kernels and understanding how these things work and how to send instructions to these devices to get the results that you want. Your your Apple Watch is an embedded system. I bet you, let's see, Apple chip in Apple Watch, or I just should say chip. Let's go to images here. There you go. All right, there you go. That's for chip, right? 64-bit dual core, Apple design. There are probably a set of pinouts and everything that you need to get that going. They probably won't release those pinouts, but again, that's what is used to monitor like your on your that's on your skin and is used to monitor. So let's look at embedded uh chips for skin. Let's go images. All right, it's something on in that monitors your heartbeat, your everything, right? That's very sensitive. That picks it's a sensitive chip that picks up everything that is about you, right? Imagine how much data Apple is collecting on you if you're pushing this up to the cloud. I then can tell you about people who live in the southeast that work from the hours of 11 to 7, what their normal heart rates are for a particular group of people. I can get that granular, right? So it's not the functionality that's important, it's the data collection of what's important. And now I know how to market to you what I need, or how to get information to you, uh, and what time of day to get information to you, right? So Linux and AWS is a good foundation to break. Yeah, yeah. Linux. When you say AWS, I say cloud, right? I don't care if it's Linux and then it's GCP or if it's uh Azure, right? Pick a cloud. I don't care. They're all going to be your functioning foundations, and understanding security is wrapped up into those learning those products, or learning about Linux, or learning about AWS. It's all wrapped in there, in a discrete manner, right? Um, let's see. Let me go here. Cloud Academy. This is one of my other ones that I use. Um, and so if we go here to AWS Web Services. All right, so let's look at learning paths. And if you look at some of this stuff, it's already has security baked into it from some level. Like you got or you have a responsibility, a shared responsibility model that you got to follow with AWS. Like, here's what we're gonna cover on as AWS, and then here's what you're gonna do if you're gonna use our platform, right? So there's some type of security baked into that. There's security of the of how you access the instances and so forth, right? That's still a thing, right? So you're gonna get all of that baked into this, and that's part of the security. That's not all. You got offense and defense, right? But that's just part of it, right? Let me start recording now.